the Carbon, Nutrient and Energy Efficient Farm 2016 to 2018. Participants in the project has been 8 educational farms in Finland and 6 universities of applied sciences as well as 4 vocational colleges. These are distributed geographically at different places in Finland. Goals of the project: strengthening the network and form common network habits between different actors and develop habits at educational farms by developing model activities. Collecting information and educational farms 2016 to 2018. Carrying out different trials and tests at educational farms. Producing and distributing information about project themes on the project homepage. Planning and carrying out a common course. The project is financed by the Ministry of Agriculture and Forestry in Finland. This figure shows the cooperational model and how we worked. We had regular meetings and common discussions, and we got this support from each other. We kept meeting seminars and webinars. We distributed the information of many different kinds of themes concerning nutrient and energy efficient and low carbon footprint as well via our homepage. And you can see here the different themes that we have been working with: biogas, energy efficiency, biofuels, composting, manual logistics, own manure, nutrient recycling, nutrient management, new technologies, protein self-sufficiency, water protection and low carbon plant production. And we have also been distributing information via social media and mostly then via Facebook. Biogas and firm biofuels. The goals has been to produce materials about production and use of biogas, bioenergy data concerning use of straw, sharing of experiences and distribution of information. On this photo you can see a biogas reactor at a cattle farm and the gas hut from this cow stable. And this cow stable had 2 robots and is located at Haapavesi. Here is a photo from inside of the gas hut. You can see the biogas bubbles in the reactor. And in this reactor at Haapavesi they use cow manure and plant materials. And the temperatures of the process is here, as you can see, 38.5 degrees. And one more example. Here you can see some of the equipment used in producing biogas, and you get from this warmth, electricity and transportation fuel. In the project it was investigated the possibilities to use rape straw at Kortesmäki farm in warming the farm broiler halls. The harvested rape straw was stored outside on the field in the autumn, and they were burnt then the year after that. During the winter there are such substances that give hot corrosion in the pan that will go away when you store it over the winter. There was also some test burning of Brassica subspecies oleifera, and it has weaker straw than rape and it goes more together like during the winter in size. So this straw was collected from circa 20 hectares, and with this amount there was produced enough warmth for 2 broiler halls and from 3 production lots during the summer 2016. This clipped straw functioned as fuel only at the farm level, as it's not economically benefiting to transport it to some other farm that is located further away. It is not believed that it's a problem of the soil fertility as you take away the straw, because more organic material is being returned with the manure, and the crop rotation has rape only every 5th year, so the straw is not collected from the same field all the time. It is possible to use the ash also from the burning as a fertilizer afterwards. At this photo you can see how straw is stored on the field and then left to be like this during the winter. Jyväskylä University of Applied Sciences Bioeconomy Institute has a goal to use 100% renewable energy. The starting point is the heating central and the dryer at the YAMK Bioeconomy Institute and the main building. And at the same they are located at the same garden, and they are then connected with a heating channel. During the heating time, warmth is produced with wooden chips, and summertime they are using oil. And oil is also as a reserve fuel for the system. The warming energy for the dryer comes from the wooden chips pan. They have also installed sun panels that produce electricity. It is reasonable to join the systems to the national network, but selling the electricity energy for circa 0.04 euro is not good to do, because when you use the electricity yourself, you save also the transfer costs, which are 0.08 euros. There has been done burning fresh wood trials in Finland. Wood is the most important renewable energy source in Finland. It is as much as 26% of the energy consumption in Finland in 2015. Heating centrals have considered wooden chips to have a better burning potential the drier the material is. But now there has been done a practical trial at Kauhajoki Kaukolämpö Oy heating company, and they managed to increase the total warm effect with even 30% and decrease the use of wooden chips when using fresh wooden chips compared with dry energy materials. The humidity functions as a warm transporter. It is easier to get fresh wood than to get dry wood materials, and this makes it easier also for the enterprises working in this sector. There is also lower risk of pests in forests when the material can be delivered fresh to the energy heating centrals. However, burning of this fresh wood suits best for large energy producers, those who have more than 10 megawatts in the heating central. We measured the energy efficiency and tried to decrease the carbon footprint. This was done by monitoring the use of fuels, monitoring the use of energy, and also by doing special energy plans for the educational farms. At several cow stables at educational farms there was installed e-gauge. E-gauge is a small box that all the electrical wires are led to this one, and after that you can follow the real-time energy use in the cow stable. Or they suit also, of course, for piggeries and different kinds of poultry production systems. On this photo you can see the e-gauge box. It's in the middle of the photo, and this is like good and possible to install it at new cow stables or new animal production units. But if you have an old one, then it may be very expensive, because not every machinery have their own like electrical barbed wire that is coming to the energy measurement place where you measure the total use of energy. So in old stables you may have many different devices under the same. No? So this is something to take into consideration if you want to use this e-gauge. Here you can see now a print from e-gauge from one stable, and this is the total energy use on this scheme. You can choose to look at 1 hour or 3 hours or 1 day or several days, 1 week or 1 month, or to look at annually how much energy you have been using, and you can see the peaks that arrive then regularly. Here you can see different devices that are connected to EGOG. So you have different colors for different devices. So the red one is the total use of energy, and then for example you can see the feeding systems and the light and the ventilation in the cow stable on separate lines. It's also possible to get a alert system to your mobile phone, so if something happens in the cow stable, so that there is an abnormally big use of energy, then you get immediately to know about it. During the project, it was made energy plans for all educational farms in the project. And this also was very difficult to compare the results from one farm to another one, because each of us have so different and specific conditions. So it was not we were not able to in that way to compare the same issues in the same places. But it functions as a good tool, this energy plan, in planning where to do your improvements, and also you can always compare one year with another year, and in that way compare your own farm with yourself in a way, and then step by step develop the energy efficiency at the farm. During the project we were collecting and reporting data of farm energy and both use and production, and we did practical experiences and documentation of producing and using of biofuels, so different kinds of tractors and other machinery, how much biofuels they were using. A case study of carbon neutrality in burning fresh wood versus traditionally dried wood as energy were also tested. And there was also made research on possibilities to decrease the use of fossil fuels, and in order to increase then alternative biofuels. There are several challenges then in messaging energy efficiency at farms, and as earlier said, it's not possible then to compare these different educational farms with each other due to this different type of technical solutions. Some cow stables are old ones, and others are built pretty newly, so that is already one very big issue concerning this energy efficiency. But it's of course then possible to compare different year statistics for the same farm. Each farm decides itself what kind of machinery that will be followed then, and or devices in the EGOG system. So all the educational farms did not follow exactly the same devices. As the farms are getting bigger and bigger, the manure logistics and the use of own manure becomes more important. The goal is to get more efficiency into transporting manure and carrying out a manure field trial, and sharing also the experience and distribution of information concerning the use of own manure. And under own manure we mean manure that actually is either produced or it comes through the production as a side stream on the farms. During the project we studied and tested the possibilities of using new manure distribution methods in order to make the nutrient circulation more efficient, and also possibilities of using the fractures in separated manure, and compare them then how effective they are to use. And possibilities also in using lake biomass as soil improvement materials and as fertilizers were carried out. There was then transport of manure and using nutrients in manure in a more efficient way in using different kinds of technology. So traditionally the transportation of manure to the fields is carried out with the same machinery, and this also distributes it at the same time where you drive it. So it means that you have to drive several times with this heavy machinery on the fields. It is possible to use the time in more efficient way by making storages and by choosing then time and using special machinery for this. At the same time, you can get also benefits from distributing the nutrients at the right time, and this will also result in less compaction of the soil. This photo you can see to the left how manure is distributed by using a tube, and to the right you can see a photo of a middle storage that is on the side of the field, and where manure is then transported by trucks on the roads. So it's there goes a lot of time for farmers by driving manure from the cow stables or the animal production units out to the fields, especially now with many farmers have also rented fields that maybe not are located so close to the animal production unit. When doing separation of manure into fractions, then the slurry, the phosphorus in the slurry will end up in the dry fraction. The nutrients in the dry fraction can then be put on porous soils, and the liquid fraction can then be used on fields with easier logistic accession, and it can be put in the fields 20 to 50% more, as there is not so much phosphorus in it. The project Sensible Agriculture produced an educational material on own manure and manure for vocational colleges. This is built up by different kinds of drawings of a farm, and you can click on the different animals or on the field and then get more information about the manure. And it's mainly contains this very basic information and calculations on different manure types. There has been ongoing several protein self-sufficiency projects in Finland concerning then growing more of them at farms. And the goal has been to increase the growing of these protein plants, and there has been made several trials with growing them, and also shared experience and distributed information about them. And many educational farms have also increased their degree of protein self-sufficiency during this project. There are several benefits of protein plants at farm level. The diversity of crop rotation and the use of the field is very good. It's improving the cultivation characteristica. It means it gives a better soil structure, and you get this biological nitrogen fixation, and you have then to use less both fertilizers, which improves then the economy of the farm as well. More home-produced protein fodder will also mean less bought fodder. There are many different kinds of protein plants, and it is possible to find suitable plants for both plant production and animal farms. For example, clover, alfalfa, vicia, peas, broad beans, lupine, rapeseed, and different types of brassica. On this photo you can see different kinds of protein plants. Finland has a lot of lakes, and many farms and farmlands are situated very close up to lakes, and that is what water protection is extremely important for us. In this project we have been done different kinds of measurements in a wetland using automatic water quality measurement systems. It was planned a wetland and measured of nutrients in drainage waters and amount of waters that are then coming into lakes from different drainage systems. At Tarvala Educational Farm there are two wetlands, and they are located next to Sumasjärvi Lake. And there are also located some then cultivated farmlands next to the wetlands, and there is an own weather station at the campus. And then there are several like main ditches that are running out the water into the wetlands. Before then the water will go from the wetlands out into Sumasjärvi Lake. The Tarvala model wetland has this water that is coming into the wetland, and this water is being monitored regularly, and different types of issues then are collected concerning the water quality. The monitored water sample results are calibrated at the end and of this measuring period. And the period in this project, it has been starting usually from April to the end of October. The dates are varying a little bit between these different years. If muddiness and total phosphorus is dependent on each other, then the total phosphorus can be calculated based on the muddiness, and that would be very good. It would be much more easier than to calculate then how much nutrients are being transferred into the water bodies. There are before also have there been regularly monitored solubility phosphorus with field analysis in the wetland. Tarvala wetland is then developed into a learning environment. It has this field area upstreams where students can calculate annually nutrient balances and connect them with the wetland downstreams, as well as then with summer lake water quality measurements. And as we have this own weather station, then it will give exactly the exact amount of rain, which is very important. The wetland gives also possibilities concerning biodiversity. Student projects have been run. For example, it can be made different kinds of plant or bird monitoring projects. The wetland is also used by a new research and development projects as a pilot area. There has, for example, been studied biopolymers in preventing and circulating nutrients, and this project has been done in the cooperation with Finnish Environment Institute and was then financed by the Ministry of Environment. At this photo you can see how the automatic measurement techniques looks like, and there are two students now also checking the equipment. This is very expensive equipment, so this is not something that each farm could do by themselves, but we need to get this research information concerning on how the nutrients are being transferred from the farmland into our lake bodies in order to do different kinds of trials and improve our crop production so that we don't have these nutrient leakage into our water bodies. During the project we focused on nutrient management and lowering carbon footprint in plant production. This has been done in many different ways. We have done nutrient balance calculations. There has been made a compost trial, a catch crop trial, the use of a drone in monitoring crop production, actions of measuring the soil carbon content, and general soil condition measurements. We have documented all the field plot actions and distributed then the information in internet. It is important to collect data on plant production and carbon footprint in order to support the decision-making process at the farm. Measuring the soil growing conditions with different methods and also plan the monitoring. Comparing good and bad field plots of the most common soils are important, and measuring and monitoring field growing conditions. Suggestions for improvements are made. Protein plant field trials and usage of the yield as food is also important. So these are mainly very basic things that usually are done at farms also, such like these soil tests and glowing, earthworm content by mustard test, for example, penetrometer measurements, and also the spade tests. They are easy things to do, and they give very good results. In the project we made different types of nutrient balance for plots, feed plots, and the nutrient balances describes nutrients coming into a system, compare them with how much nutrients goes out of the systems. You get either a positive or a negative result of the nutrient balance, and the balance calculations are usually informed per 1 hectare, for example kilo per hectare, or as a production input relationship, an utilitarian percentage. Nutrient management and balances were calculated for Mustiala, Tarvala, Koivikko, Peltosalmi, Korpia and Tuorala educational farms. And growing conditions were very different in these different farms. For example, the length of the growing period varies as we are located in different geographical locations. The soil types varies. And there is also difference in what kind of cultivated plants there are, and the yield and fertilizers level also differs. It is challenging to collect this basic information at farms, and also the calculation methods differs. Results of field balances shows directions and are comparable with former similar research results. There were big differences on different field plots and for different plants cultivated even at the same farm. Some few points about the challenges with calculating nutrient balances. The estimation of yields, if you don't have the scale at the farm. So not all farms are really measuring how much yields they are getting, for example, of green fodder. And if you don't have this scale, you cannot do this, and you have to estimate it, and then it is not so accurate. Also, the accessibility of yield analysis is important. You have to estimate the nutrient amounts that are freed from the manure. You have also to estimate the biological nitrogen fixation, and you have to estimate the soil mineralized nitrogen intake by plants, evaporated soil nitrogen and soluble nitrogen in the soil. So you need really precision of documentation in order to be able to do these calculations. The results do not tell about the real influence of the surplus nutrients. It shows more the potential environmental load. One has to take into calculations farm-related factors also, and the weather during the growing season. At Mustiala Educational Farm, for example, it was tried to draw up the nitrogen balance and the phosphorus balance. And you can see the size of the arrows a little bit, how the streams and what kind of nutrients are going in what direction. At Västankoan farm, they were done a compost trial. 2 compost trials were carried out in 2016 with horse manure with a lot of straw. One was had free enter of oxygen and another had limited entering of oxygen. Samples were taken after 132 days. Both trials had the same amount of nutrients kilo per tons compost, and it was done on 100% dry matter. From the table you can see related phosphorus amounts that resulted in less carbon, total nitrogen and potassium. And for all of them they were less in the limited oxygen entry compost. As a conclusion, we can say that composting gives a lot of losses in nutrient and carbon especially. Soil fertility benefits most if non-composted organic material is added to the soil. Composting suits such organic waste that has to be homogenized in order to make it hygienic or in order to make the transport easier. At Mustiala and Novia educational farms, they were made out also catch crop trials. The collection of data at educational research farms is very important. For example, at Mustiala educational farm, all the field plots were documented and all the cultivational actions were put open on internet. It was produced an interactive map, and by clicking on the field plot it opens up a page where you can see what has been cultivated on that plot different years, and also when at what date the different activities has been carried out on that field. Also the soil analysis results are found on this page. During the projects there were done several trials with using a drone and making photos of the fields, and we managed to identify a lot of benefits from doing this. For example, it is possible to foreseen what kind of yields there will be coming, even more than 1 month before the yield is ready to be harvested. We made virtual field plot cards and put into those then these cultivation actions, yields, nutrient balances, photos, maps, drone pictures and videos. During the project there were made observations weekly and the stage of plant growing and taking photos regularly from a certain amount of fields. And we made also different kinds of developments in interpreting the maps that are received from drones, connected then to both weeds and pests and possible yields that you may have from this field. The results of the research are open at internet at the project homepage. During the project, several new technologies were tested and information about the use and guidelines were also written down. We tried to use the 360 camera and made photos of our fields with that. EGAUG were used, and then we used also a chlorophyll which took information about nitrogen, temperature and leaf indexes on the plants. Several educational farms got a scale to measure the yield weights because this was missing, and also it was percashed grain sense measurement which measures protein, humidity, oil and carbon content. And this is a very good device because you can actually before harvesting already get immediately out in the field the results on concerning your yield. And this device is then calibrated like with the mother laboratory, so you don't have to send the yield to a laboratory in order to get the results. And also the amount of yield that you need in order to make this test is very small, so it's very quick to do these tests. It helps also you, for example, in planning where to put your yield after the dryer. The protein content helps you also in deciding how much you need to percash proteins for your animals if you are mixing yourself the fodder for the animals. When percashing a weight or a scale for your tractors, then it's important to pay attention to the width of the scale. So if you are buying new machinery that are wider, then perhaps they are not fitting into your scale anymore, and that's why it's a good idea to percash a system that is adjustable. And many of these systems also require that you make a concrete plate and then put this scale into that plate. So that's also a cost that you should remember. Several educational farms got a drone, which then has been tested together with students. The education, our students and our cooperational partner has been in the heart of the project. During the project, several educational farm visits were made. The data obtained from this project has been integrated into education. There are more than 35 courses and modules that has been using this information. We got also several final theses and student projects related to the themes in this project. There was developed a course, a 5-credit course on nutrient and energy efficiency, and it was carried out summer 2018 at Savonia University of Applied Sciences. We made also several webinars, which of 6 were a type of short information occasions of only 30 minutes, which easily could be integrated into ongoing education, and we distributed them and recorded them then online. Our webinars were also part of the Finland 100 years of independence celebration. We cooperated with a lot of other projects ongoing with similar topics. The project participated in several other project happenings, telling about our project results, and we also participated in several large agricultural fairs, as well as research days concerning energy and nutrient efficiency. And the project also made several posters. The results of the project has been distributed openly at internet and by using social media.